Great. Well, thanks very much, Monique, and welcome everybody. This is my first webinar. I haven't done a presentation to a big group like this by myself on a screen, so this will be kind of fun and interesting. But I really appreciate everybody logging in, and I appreciate the background that Monique provided. I'll start just by telling you a bit about the Southern Alberta Land Trust Society. I've got control of the slides here. It's a bit clunky as I try and scroll through, so just bear with me if for some reason they don't transition quite as smoothly as I'd hoped. Hopefully the audio is clear. Everyone can hear me clearly. Monique, it's good?
Right here, yep.
Excellent. Okay, good. So in terms of presentation today, I'd like to get through the slides reasonably quickly and leave a fair bit of time for questions. I think questions, but also comments. This is, I think, a fairly unique project and sort of one of the first attempts of its kind, and it certainly, I hope, over time will get improved and upgraded. And so if anybody on the call has ideas on how to make this type of prioritization more accurate or work better, I'm really interested to hear that feedback as well. So we'll try and leave quite a bit of time for some back and forth. In terms of the presentation, I'm just going to talk briefly about SALT, who we are and what we do. Talk about the genesis for this project. What is the need to map areas of priority for water, and where did that sort of begin? And then I want to go through the actual project methodology. So how did we go about creating these maps? And then what were the outputs and products that we wanted to have as tools for anyone working in a watershed to preserve watershed health? And then I want to talk about some specific applications for different potential users of these products, and then we'll move into comments and questions. So SALT is kind of an interesting organization. It was actually started 20 years ago this year by a group of ranchers and landowners who really felt that it was beneficial to have people who were engaged in the management of the land, in conservation of the land. And so back when the federal government put in place early rules around ecological gifts and receiving some charitable receipts for ecological gifts, a group of ranchers in the Pincher Creek, right up the Longview area, started the organization, and it's sort of been growing ever since. We're a nonprofit organization, obviously, and we're a federally registered charity. And since we started 20 years ago, we have put conservation easements on over 21,000 acres through more than 40 different agreements, voluntary agreements with landowners in Southwest Alberta. And some of you are probably familiar with how we do this, but basically we use a tool called a conservation easement, which is an agreement that goes on title of land in perpetuity and places restrictions on future development on that land with the intent of maintaining the conservation values of the property. And those conservation values can be very broad. They can be watershed health, wildlife habitat, critical wildlife corridors, native grasslands. And so that's how we do our work. And, SALT is very much focused on preserving those lands of highest ecological value. But we also, one of our other goals is to help ranchers and people working on the land to stay on the land. So that's another part of our objectives. And I just wanted to add in here, it's on the slide, but the Alberta government and AEP has a program called the Alberta Land Trust Grant Program. It was started, I think about 7 years ago now, and under the Land Stewardship Act and the Land Stewardship Fund. And that program has been immensely valuable in helping organizations like mine and other land trusts to protect critical habitat and critical watersheds. So I guess the question is, what is it that we're trying to protect from, or what are we trying to conserve? And if you look at these maps that were done by ALCES, and some of you may know Brad Stelfox's work, this particular set of maps just looks at the human footprint, non-agricultural human footprint on the land. So roads, houses, gravel pits, any kind of sort of disturbance on the land. And you can see from 1960 to 2010, and this is just the Eastern Slopes, Southern Eastern Slopes, that area of Calgary, Highway 1, Cochrane, Canmore, and then all the way down Highway 2, there's been this expansion of human footprint. And if you take that same growth rate and just assume that same growth rate out into the future, you see that footprint on the landscape in terms of human footprint expands well into the foothills west of Highway 22. It's quite significant, and we will probably be able to change that trajectory somewhat through different planning, and hopefully the SSRP influences this trajectory. But the fact is, we're going to see more and more growth. We realize we're not going to stop all development, nor do we actually want to stop all development. But we'd like to, along with our other land trust colleagues, be strategic about preserving those areas that are of highest value for watershed health, for wildlife habitat. And I think what a lot of people in cities, for example, don't realize that as our populations in our cities grow, we have this increasing demand for ecological goods and services, be it clean water, biodiversity, recreational areas, open spaces. Our demand is going up for these things, but of course, as our footprint expands, we're actually reducing the capability of the landscape to provide these ecosystem goods and services. So we're setting ourselves up for a bit of a wreck here in the future if we don't make sure that those ecosystem goods and services are preserved to support our growing population. And a good example of that, actually, which I'm really pleased to see, is that the City of Calgary just recently released their source water protection plan, and they identified two top risks to Calgary source water, one being a major fire in Kananaskis, but the other being increased residential development upstream of the city, which results in increased stormwater runoff that is very hard for the city to treat. So here you have this direct link between expanding footprint and development west of the City of Calgary, creating real costs or issues for water quality downstream. So, we're starting to really understand these linkages between the ecosystem goods and services and the needs of our population. So salts, we already do conservation easements that help to protect water. We've done conservation easements, not just on the riparian areas, but the adjacent areas and the adjacent lands. And that means we're reducing roads, houses, gravel pits, cultivation, all these things that, help to keep the riparian area healthy. We've already done easements on places like Fish Creek. We've done easements on, this is Pekisko Creek in the Pekisko Valley by Bayou Ranch. Done easements on Chaffin Creek. This is just by Highway 22, south of Chain Lakes. Done easements on Olin Creek and many other small creeks on the west side of the Porcupine Hills that flow into the Oldman River. We've done easements on a big stretch of the Crow's Nest River near my family's property, which are keeping this area that has a lot of pressure for rural residential subdivision and recreation. We're keeping those areas undeveloped. We've done easements on Mill Creek down just coming out of the Newcastle Wildland Park. We've done easements on Yarrow Creek coming out of Waterton and the far south end of the Castle Park. So we're already doing easements on creeks and rivers and the adjacent lands to keep these areas healthy. But that's just by virtue of the landowners who have been approaching us and knowing that, obviously creeks and rivers are important for a whole bunch of things, whether it's fish habitat or water quality. But it hasn't been as strategic as we'd like it to be. The challenge is that we haven't had a good way to link those areas of the landscape that have high value from a water standpoint spatially to allow us to prioritize those areas. We know that wetlands are important and the buffer around them. We know that rivers and creeks are important and a buffer along them. But there's also areas of the landscape that are away from rivers and creeks and wetlands that, because of the nature of that landscape, also provide important flood mitigation, water storage, water quality value and function. And that's the spatial piece that we were missing in terms of identifying these areas. There's been mapping done to assess watershed health and to identify risk areas. But again, for organizations working on the ground on specific parcels, those mapping exercises were at a very, very macro level. So if we look at some of the mapping that was done, for example, to look at drought, flood, and water quality, the whole southern part of the province has been identified as high priority for drought. And then when you look at flood and you look at water quality, similarly, these huge areas. Well, as a land trust, within any one of those sub-basins, there are going to be areas that are more or less important for drought, or more or less important for flood, or more or less important for water quality. So this kind of macro level mapping helps, for example, when municipalities or governments are looking at mitigation or investments on a very macro scale, but it doesn't help us down on the ground. Similarly, there's been efforts done in a lot of watersheds. This map on the the right is an effort by the Oldman Watershed Council to look at the health of the watershed. So what they looked here was landscape intactness, so levels of linear disturbance in fourth order watersheds. And so those watersheds that have a lot of disturbance are deemed to be high risk, which again is helpful in terms of understanding which watersheds are badly damaged and which ones are still healthy. But for me, as a land trust wanting to preserve habitat and hydrological function, these maps, I may still want to protect land in the area that's high risk, or I may want to protect land in the areas low risk that might be developed. So again, these things identify health, but they don't allow organizations working on the ground to target and focus their efforts. To this date, up to this point, SALTs, we've been doing a lot of other type of mapping. And for example, we will map areas of critical wildlife habitat, native vegetation, species at risk, but we've been really missing that water piece other than just knowing where the creeks, lakes, and rivers are. So the map on the left was an exercise where we did a conservation priorities overlay with habitat suitability models for grizzly bear, winter ungulate range, species at risk data, and native vegetation. And so this map helps to show us where parts of the landscape support the most of these conservation values. So really valuable from a prioritization and focusing our efforts. The orange and red being high priority, the blue being lower priority for those specific values. We did a similar project, what we call the Cowboy Trail Project, south of Longview down to the Waldron Grazing Co-op, where we used data sets around wildlife, native vegetation to try and identify those areas of highest priority from an ecological standpoint. But again, when it came to water, all we were looking at was the actual water features. So as a result, SALTs applied for WRRP grant and were successful, which was great. Thank you, WRRP, because what we wanted to do was try and get a better handle on this challenge, this problem of spatially representing areas of the landscape that were important for water. So what we did was we actually pulled together a group of participants in a workshop. I worked with a consulting company called Associated Environmental, because Associated had recently done work with the city of Calgary on their modeling around their source water protection. It was a bit of a different approach. They used some different inputs because they were more focused on risk to water quality versus sort of maintaining landscape health from a water standpoint. But we worked with Associated Environmental, but we really wanted to get the input, obviously, from a lot of key players. So this was a group of people at the workshop, and we had people that were experts in hydrology from the geography department. We had people that knew about different data sets. We had people that were knowledgeable about GIS and mapping, but we also had people that were working on the ground. So I wanted to make sure that what we produced and the work that we did actually was useful for people like Cows and Fish, the Oldman Watershed Council, land trusts like ourselves, to make sure that whatever we produced was actually going to be a useful tool for the people working on the ground. So the simple sort of overview of the methodology was to first identify those landscape layers that the group of experts felt were representative of watershed health, and then to categorize each of the attributes in the landscape layer using a risk score of 1 to 4. And I'll talk more about that, but to categorize what was essentially important down to a less important rating of that landscape feature. Then we would take all those landscape features and overlay them and combine the scores to create an overall rating score for all the polygons generated in the map, to try and really highlight those areas that have the highest value for all those landscape layers that are important for water. Then the next stage was to classify the rating scores into categories, and I'll show you what we did a bit in terms of looking at different ways of mapping the watershed and prioritizing in different ways. We then circled back with that group and showed the group what different modeling approaches and mapping approaches looked like on the ground, to try and get input from people who knew specific areas of the landscape to understand whether they felt the mapping was actually representative of what was going on in the landscape. Because as I'm sure all of you know, a lot of these data sets we use, some of them are very coarse, they aren't always an exact representation of the ground. So it was very important to go back and sort of ground truth the final overlay to make sure it was actually representative of what people thought was on the ground. And then the final product was to create, I'll show this to you, a sub-basin roll-up, so to prioritize based on sub-basins, as well as a detailed map book that allows people working on the ground to really focus their efforts. So for some reason on my screen, I apologize, I can't actually see the bottom part of my, the very last part of my slide. So I'll have to wing it, but these were the layers that were chosen, and we can chat more about why these layers are chosen, and there's a little more justification and background in the technical report that I'll make available. That'll be available to everybody online. But they're actually not rocket science in a lot of ways. They're sort of based on common sense. One being precipitation. So where more water is falling on the ground, there's more opportunity for flood, more opportunity for water quality issues, more opportunity for water storage. If there's no water falling on the ground, then those areas of the landscape are not going to be as important for providing water services. Proximity to wetlands and lakes is a key one, because of course the closer you are to those water features, the more impact there is potentially on flood and water quality. Proximity to water courses is even, and I should have talked about that first, sorry, proximity to water courses in some ways is more important because there's more issues often with filtration and flood conveyance. So proximity to wetlands and lakes is often more of a storage issue, and potentially an issue with aquifers. But proximity to water courses is even more critical from a flood and water quality standpoint, because the closer you are, obviously, if there's more disturbance, the more risk there is of siltation and faster runoff. Aquifer vulnerability was a layer people wanted to include in terms of the, obviously it's important for us to preserve our aquifers, and surface disturbance can have a negative impact to aquifers. Land cover being the vegetation, what's on the surface, and how does that land cover interface with water. And the assumption here was that if you've got native vegetation, it's going to do a better job of both storing water, but also filtering water and slowing it down than if you have developed landscapes like roads or concrete, or even farmland that may provide some benefit, but often can also provide water quality issues if there's runoff across farmland. Slope was another key factor. Obviously, if there's higher slope areas, that can exacerbate runoff and erosion. And the last one was soils and superficial geology. This is one I can't see on my screen, but obviously having soils, some soils are more susceptible to being eroded and having a greater impact on water quality. So then the next step, which was challenging, was to actually to rate these different landscape layers from low priority to high priority. And so there's a lot of discussion within the group about how to break this down, but basically precipitation was broken down. Precipitation was broken down somewhat by the natural subregions. So we know that natural subregions are highly influenced by precipitation regimes, and so when trying to look at how to cut different precipitation data, we looked at also natural subregions in terms of how to represent that across the landscape. And that was a recommendation of people from the U of L Geography Department. Proximity to water is a simple one. It's either you're within a certain distance or you're further away, and we'll talk more about that. Aquifer vulnerability just went from very high to low. Land cover, we basically took all types of native vegetation and gave it a high rating. There was no high, very high, and there was no high. Agriculture was moderate, and then of course low was developed areas or exposed rock. Now slope was an interesting one because slope has a bunch of different factors influencing hydrological function. There's flat areas can actually store water and allow water to go down into aquifers and the water table. And so it's not that flat areas are not important, but in this case, we were trying to look at things like water quality and flood. And so we actually broke the slope down where 0 to 10 was moderate, 10 to 20 high, and then very high being 20-30. Even though water does, at greater than 30% slope, you've got even faster runoff. The concern here was that it's highly unlikely on both public and private land that people are actually going to build roads or houses or infrastructure on a greater than 30% slope. And so if we'd made greater than 30% the highest, it would just sort of accentuate all the mountains and rock. And really what we're trying to get at is which of those areas do we want to avoid development? And of course, the high slope areas are areas that aren't likely going to have development anyway. So what we wanted to do is prioritize those areas that were steep and would have maximum impact in terms of runoff rate and siltation, but that were still low enough slope that people might actually try and build roads and houses on. So that's the rationale anyway, and we had lots of discussion and debate about that, and I'm happy to entertain questions. And then the last one was the superficial geology, and this was just looking at those soils or superficial geology that again are more susceptible to erosion. So then the next step after rating them between 1 to 4 was to actually look at, were all of these various landscape layers equivalent on the landscape? Do they have equivalent impact? And so this was an interesting debate because you can make them all equal weight in the overlay, or you could say that some are more important than others. And at the end of the day, the group decided that some were in fact more important than others. And there was both an issue around which ones influence, water quality and hydrological function more, but also some of these data sets are very, very coarse. And so there was also concern around the accuracy of the data set. And if you made those data sets equal to other ones, it would distort the eventual overlay and the outputs. And so as a result, the group came up with both a data quality rating as well as an importance from a watershed health standpoint. And then that resulted in the relative impact or weighting for each of those characteristics that went into the overlay. So I'll just run through each of those layers so you can see what those actual sublayers look like that end up creating the eventual overlay. So this is the precipitation map. I'm not a huge fan that the data set was kind of pixelated along these, rectangular boundaries along each layer, but that's the way the data set came out. And so you can see this sort of succession in the Oldman watershed of high precipitation in the southwest corner, heading to lower precipitation as you move east. And we tried to find a data set that was more recent with the idea that hopefully the last 30 years between 1980 and 2010 were more representative of future precipitation regimes than if we had an older data set. So there was lots of discussion around data sets. This is proximity. So we took a whole bunch of different layers for the water proximity rating. It was, and you can dig into that in the technical report, but we had wetland layers, creeks, rivers, and so you can see it's fairly extensive. And the argument here was that even small creeks should be included because in a major rain event, an ephemeral creek, may not provide a huge amount of water year round, but in a large rain event, if you disturb next to that creek, it could provide one, higher flow rate, but also if it's the right soil conditions and the right slope, a lot of siltation and dirt into the watershed. So the decision, and this was another big debate, was to treat all water courses essentially as equivalent in this priority rating. Groundwater vulnerability. This is an Alberta government data set that we utilized. Land cover. This was an interesting combination of grassland vegetation index and the ABMI data, ABMI land cover. And from my past work, I just had a lot more comfort with the GVI data set on the eastern slopes. But of course, the GVI data set doesn't cover the whole area. And so we actually merged the two data sets to create one overall land cover rating of farmland, native lands, and then developed areas. And here's the slope rating. So this is interesting because, of course, again, you know, so many, the historic sort of simple watershed approach has said that the very tops of the rocks in the mountains were the most important thing for water. Well, it's true, that's where we get the most snow. But if you're worried about water running off quickly and being dirty and not being stored, there's not a lot going on the very tops of the rocks, the tops of the mountains. And even if you do put a road up there, it's rock anyway. And so this is a little bit of a different perspective where we're saying those areas that have soil that are steep and could be developed are the areas that have the greatest sort of value to the watershed and are in higher precipitation areas. So what you'll see is that there's these areas in the foothills, the river valleys, and the Porcupine Hills in this case, that are those areas that are higher slope, but not so high people couldn't actually, you know, develop on them. And this is the surficial geology soil map. Again, it's a very, very large, it's very macro scale, not a lot of detail. And so again, that's why it was kind of discounted a bit, because we know that within these polygons, there's probably a lot more complexity, but that was the only one we had available. So from all that, what in the end did the project create? So the first one was to take all those layers and to put them into an overlay. And this is the overlay map. And there was lots of debate about what color scheme to use. And I apologize if there are folks that are red-green colorblind. This is probably not a great map. And there's lots of discussion about how to best represent this. But at the end of the day, we chose sort of a heat map approach for this map, where those areas that are red, orange, yellow had the highest scores across the greatest number of those landscape values. And then as you moved into the light greens and greens, those are typically areas that are flatter areas, they're agricultural, and they have you know, less precipitation. Now, again, this is not a point source pollution risk map where you're looking at agricultural inputs from feedlots or various things. This is saying what parts of the landscape do you want to keep intact to maintain hydrological function. So it's very important to understand what the purpose of this is, because obviously if you looked at a map from a point source pollution standpoint and you're concerned about, you know, phosphorus, nitrogen, those sorts of things, this map would look very, very different. Oops, sorry. So the next map we did was to say, okay, we've got the detailed overlay, but which of each of these watersheds, these sub-watersheds, contain the most area that is high priority? And this is important because often watershed action happens at a community level. And so if you've got a watershed group, it's often based around, you know, the Todd Creek watershed or the, you know, Rock Creek watershed or the Mill Creek watershed group. And so it was important to actually look at each of these sub-basins and say which of these sub-basins has the highest percentage of area that is in those high priority areas. And one other thing to do, looking back at this macro map and then the sub-basin map, is also to look at jurisdictions, because we often think just about crown land or just about private land. The goal here was to show that we have really important parts of the watershed, both on public land, but also on private land. And so as a result, we need to look at a whole different suite of, a broad set of tools to look at watershed health, both on how we manage our public lands, but also on tools that can help to preserve watershed health on private lands. And so that's why the reasons the blue line is essentially on this map is the boundary of the green zone. You can see First Nations lands in brown, and then everything else. I mean, there's obviously some grazing leases in there as well, but almost everything else is private land. And so you see that both private land and public land are going to be key parts of the solution for long-term watershed health. And it's the same on this map. You can see that a lot of these important watersheds sit on public land, but they also sit on private land as well. So those maps are useful in terms of the broad context of which areas of the landscape are important, but we really wanted a tool that allowed us to zoom in. So we created a map book that broke the watershed down into multiple panels and then allows users to zoom in down to a very detailed level. So for example, this map you can go in one of the tiles and it shows you roads, water courses. It shows you the sub-basin with the numbers on it, which you can correspond to the map book table. In this case, on this map down in the far southwest corner, this is the edge of public lands, green zone. All the hatch marks are grazing leases. So you can see areas that are grazing leases on, these are crown land, and then you've got all the public land. I mean, the private land that doesn't have, either isn't in the green zone or isn't grazing lease. And so this level of detail allows us to look at the landscape based on an individual quarter section, based on a ranch, and you can engage a landowner around potential stewardship around their particular property and say, hey, wow, look at your property, it has all this orange and red. It's really important for watershed health. How can we bring resources to bear? Another example is saying, if you're going to talk to a funder, you can say, look, we're trying to work with a rancher to preserve this part of the watershed that's really critical for long-term water quality in Lethbridge. It's preserving the water quality in Lethbridge. One other interesting feature is this hatched dashed black line is actually everything to the sort of south and west of this flows into the Oldman above Lethbridge. So Lethbridge is drinking water, and everything to the north and east of it flows into the Oldman downstream of Lethbridge. So another sort of interesting context piece to help, for example, the city of Lethbridge understand if they want to make investments in the watershed, which parts of the watershed are directly feeding into their drinking water. So this is the kind of level of detail that I was hoping for in this project to allow us to really understand where to focus our priorities. So in terms of applications, and I'll try and wrap up here quickly, obviously a big one for us is to say which areas of the landscape do we want to actually go after to do conservation easements on to reduce fragmentation. It also helps people like cows and fish to say, we want to work with this rancher around off-stream watering, riparian health, to improve riparian health, because this particular property has really high value from a water standpoint. Municipal governments could use this to say, if we're doing zoning, maybe we shouldn't zone, higher residential development in these areas of high watershed value. It could actually support planning on public land for new infrastructure. So if you want to build new campgrounds or new roads or trails, maybe we should avoid those areas that infrastructure is more likely to cause negative effects on the watershed. I mean, I know they do the micro planning around trail slope and making sure the engineering of the trail is right, but you may even want to look at where to put the trails on a bigger scale or not put them. And so at the end of the day, really the goal here was to try and make the spatial link between areas of the landscape that are important for hydrology and water surfaces to make that a useful tool for people on the ground. So a few examples. So here's this area. This is a landowner on the Waterton River. And so now if a landowner contacts us or we want to reach out to a landowner, we can use this map to say, okay, based on the slope, the soil, the precipitation, the proximity to the river, wetlands, your area comes out as high priority. It has areas of really high priority on the landscape. This is something we use to communicate and engage partners in a stewardship project. The other example, of course, is on a really big level. This map shows that the work the government's doing, the castle is obviously really, really important for water, and we know that. But this is one more tool that just says, when you look at this particular analysis, the castle comes out as very high priority. And by the way, all the recent planning efforts on the Porcupine Hills and Livingston around the linear footprint plan and the recreation plan, oh wow, these areas are also really, really important from a water standpoint. We know that, but this just confirms it using this particular methodology. And so another potential application is, for example, this is a portion of the Oldman watershed just north of the Crow's Nest Pass. And that's the Forestry Trunk Road Highway 40 coming north of the Crow's Nest Pass. And so this is kind of a bit of a hack job that I did, but I overlaid, these are some of the new OHV trails that are proposed in the new rec management plan. And so this could be a tool in the future when looking at campground sites, new trail infrastructure. Where do you generally in the landscape want to go with areas that if they're disturbed more than others, they're maybe not going to have as much impact on water quality and runoff. And so that's the existing trail. The plan also proposed new motorized recreation over in this area. And so the question is, well, okay, if you're going to do motorized recreation in that area, this is an area with a lot of slope, a lot of water courses, and features that are coming out as really high priority to avoid disturbance. So how do you actually plan infrastructure in that area in a way that doesn't have a negative impact on water quality? So that is a really quick and dirty summary of the project. And I probably left out a whole bunch of detail, and many of you I know are probably experts in a lot of these areas, probably more than I am. So I'll open up to questions. I will say that the technical report, all these maps can be accessed on our website, just www.salts.land. And then you can actually go to maps and there's a link to it, or you can go to publications and there's a link to all of these maps and the report.